In Java, you can access the data or fields and methods of an object through its reference variable using the dot operator. This is the topic that we're going to explore for accessing data, as well as the method using it. Idea is very simple. Once you have the reference object, let's say this being your ref object, there's a whole bunch of data in it. These are attributes, properties we talked about earlier. There's also a whole bunch of methods in there. Assuming these data and methods are accessible, we'll talk about the access modifier later on. They could be accessed by directly using object reference variable name and the dot operator. Let's do a test run to demonstrate this. This is the circle class we looked at before. We're dynamically instantiating or creating an instance of it, and this returns the memory address of that newly created instance back to my circle, which is a reference object. This reference object references or has a pointer or memory address leading to this instance. Since my circle is a reference object, we can make use the dot operator later on. Let's look at this other declarations. Whereas on the left side, we have dynamic memory allocation, which means this my circle sits in heap memory. Whereas on the right side, just by declaring my circle, obviously you have to have circle in front, the name of the class. There's absolutely no value associated with my circle at all, because there's no equal sign, there's no assignment, so nothing assigns into it. So by default, there is a null keyword associated with this. This means my circle is not pointing to anything. This also means that this reference variable has just been declared without any assignment. When doing that, you have to have a semicolon here. So these are two ways to create this reference variable. One is you can just create it on a stack. Since there is no new, this thing sits in a stack memory. The other way is to dynamically allocate a space in heap and assigning its memory address to my circle. Either way, you can use the dot operator for the heap examples. The reason why you can do it is because this new guarantees in this memory space called heap, there is a dedicated slot and dedicated memory address for this circle object. And the reference for that circle object in memory is your circle in this case, or my circle in that case. You can use dot operator, assuming radius is publicly accessible and or it's accessible by your circle object. You can use that dot operator to get it and also to set it. In this case, we're setting 100 to be the value of that circle's radius. Let's look at the next frame. We'll go through this one at a time. New circle, like I said before, creates a circle object. This is the UML class diagram. This new circle creates a circle object. There's no reference pointing to it because we're simply allocating memory spaces, assigning a value of 5 to the radius. And this entire thing sits in a heap right now. A circle is dynamically created, period, through this line. Next, we have the assignment operation. This assignment operation effectively assigns the memory address of this entire object in heap to my circle. My circle, as we know, is a reference variable. So this association assigns the memory address to it. For the sake of illustration, let's say this memory address is 0 times FA2. Note, in computer science, memory address is always in hexadecimal format. That's why we see this 0 times blah, 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 alphanumeric. So that's your reference value, memory address, by way of using this assignment. Remember, new is a keyword that returns a memory address. Let's move on to the next frame. Let's look at this other example, creating a your circle with new circle. Initially, if we just do a declaration, this creates a reference variable that has no value to it at all. Because if we're simply just looking at this, same thing with my circle initially, there's just no value associated with it for declaring that reference object. Let's move on to the next frame. We dynamically allocate a new circle instance here with a radius 1.0 by default, since there is none. Don't worry about the class template, how it was defined. Just note that this new operator returns the memory address of this. Let's say 0 times zk2. Next up, we can see that by way of using this assignment operator, you're assigning the memory address of this newly created instance here with the address of 0 times zk2 to it. And that becomes the value of that reference object, your circle. So again, new returns the memory address of the newly created object back into the object reference. Let's move on. So now we take command of your circle, fully declared, initialized with the address or reference of a valid dynamically allocated object in memory. We can make use the dot operator, your circle dot radius, to access its internal data or data member or property or attributes or fields. In this case, we're setting 100 to it. This is how we change radius in your circle. Recall previously we used some Java libraries such as math to invoke its methods or data even by using the dot operator. What you have is a class name and dot its methods or data, such as math.power. The question is whether we can invoke getArea from the circle by using simple circle.getArea. The answer is no. The reason is because math is declared as a static class. This means math is of the class, but not of the instance. What does that mean? Math does not need to be instantiated. It is static. There is one copy in the entire program. We'll look at this static keyword a little bit later. GetArea is non-static because its circle object is not declared using the static keywords. Instead, that simple circle, as we saw earlier, is dynamically instantiated using the new operator. Basically using new to create something, that something is not static. So if this is not a static variable, you will not be able to make use of its class dot, the method name. You have to use that instance name. Object reference var dot method name will be the key and not circle dot method name, because circle is not a static class. We'll go through this as in static variables, constants, and methods section. This is a public class declaration that has several data, member, student name, student age, and whether the student is a science major, true or false, and his or her gender. By the way, every time we talked about something that is inside a class, we start with the word member. So this data field becomes member data field. As you can see, we can use other reference types like string, even primitives inside a class. Imagine you can have a class student with some of the other user-defined classes later on. And inside of those, there's more user-defined classes. You can create these nested objects or Java plain old objects on your own. You can make references of each other and access each other's data using the dot operator in Java. We'll look at polymorphism. We'll look at inheritance and some of the other OOP features to enable object-to-object interactions later.